Hi all, thanks for joining. Hope you can see my screen. So today we have the second edition for Epic Champion Hours. So the first session was for DAM asset and tools and practices which we use. So that you can find in the YouTube. So the agenda for this session, we will go through like what is the champion program, what is the mission for the Epic Hours, introduction for the panelist. So today will be the first part for the performance optimization, where we will go through the core web vitals as well as the front end and back end optimizations. In the part two, which we'll be having in the next week, we will go through CDN, caching and hosting optimizations. Then we will answer like any pre-submitted questions or the live questions in the session, and then it will be a wrap up. So what is a champion program? So champion program, AEM champion program basically recognizes the AEM practitioners which are playing a key role as a thought and industry leaders in the market. And the champion program helps them to share their technical expertise, best practices, and strategies with the broader community. It helps to collaborate with the product leaders of Adobe so that they can provide the feedback for the future versions of Experience Manager, as well as get the sneak peeks on what is coming next. They can share the knowledge and network with the AEM users and community. They can also engage in exclusive speaking at Adobe Summit's Content Creation and Experience League, and it can help to increase their personal branding opportunities. You can apply for this year champion program and also connect with Robert Solby, who is the manager for this program. Just like LinkedIn, like message him and reach out to him for any queries you have for the program. So what are office hours? So office hours are kind of basically monthly sessions. So it has been started for the APEC region from last month. So the aim is to have a session each month so that the topics which are like asked by the users or something we find interesting, we share it. And also it gives an opportunity to interact with you guys. So let me have a brief of the today's panelists. So myself, Deepak, I'm working as a principal engineer, and I'm also part of a AEM leadership community. Devanshu?
Hi guys, I'm Devanshu Goyal, Senior Consultant at TechX. Thanks for joining everyone. Over to you, Venkatesh.
Hey, hi all, I'm Manish, multi-solution architect for Adobe platform in Qatar Airways. Thanks for joining.
Thanks, Venkatesh. So when going through the performance optimizations session, like first thing I wanted to let you know, like what are web vitals? So Google has a vested interest. They want to serve the good web pages because if the pages are loaded fast, then it will give them more ads and budget. So that's why they created the core web vitals as an initiative so that our AEM sites performance can be standardized across the all sites over the internet. So what are web vitals? So web vitals are basically a set of metrics which measures the real world user experience for loading performance, that is content loading, interactivity, as well as the visual stability of the page or the sites against a standard. The standard by which all the sites are measured is measured against from a data which is collected from a Chrome user experience report, also known as CRUX. And so the data which is for the core web vitals report comes from the CRUX report. It's your basically a publicly accessible collection of all the real users experience across the sites, and based on that performance, a matrix or a baseline is created out of which the core web vitals score is being considered. Hence, the web vitals show how far or below like our site is performing in some areas as compared to all other sites on the internet. So after the introduction to core web vitals, so why it is important for the AEM sites? So Google announced in 2020 that web vitals will impact the ranking on Google search engine results page, and it was rolled out algorithmically also in August 2021. Hence, having the good web vitals are very essential for SEO as well as the performance. Hence, it is imperative like for all the site owners to achieve the good core web vitals so that it's for the success with search, so that they don't lose the traffic. Also to ensure there is a great user experience. There are some ways to measure the core web vitals. One is the page speed insights. It gives us the data like under both lab conditions as well as the real-time data. I will show you in a minute. Internally, PageSpeed Insight uses the Lighthouse to analyze the URL in a simulated environment for the metrics like performance, accessibility, best practices. And PageSpeed Insight also shows us the field data. So what is the field data? Field data is the actual data which is being used by the Google for the score computation for the core web vitals. It comes from the real user interaction over a period of 28 to 30 days. So whatever the performance experience of the real users for a site over a period of 28 to 30 days, the best 75 percentile score of that is being considered as the field data. How do we know like which devices are being used? So basically we can go to our analytics and see what are the devices or smartphones which are used, see last 30 days which are being mostly used, and try to see the score for those devices and try to fix it. So as I mentioned, we can understand the performance score by some tools. One is the PageSpeed Insight, one is the Lighthouse. Let me quickly show you also. So this is the PageSpeed Insights. I have entered a URL. My friend Joshua asked me to check for performance optimization. So we can enter any URL. So if you see, it will show us a separate tab for mobile as well as the desktop. This URL means specifically this page only, the home page. Origin is basically all the pages across the domain. So this is the basically the field data which I was saying, which is the real user experience over a period of 28 to 30 days. So this is the score, and the top 75 percentile score is being shown here so that it gives the site owners a chance to improve it. And also we can see the lab data, which is the data currently under the server used by the PageSpeed Insight. So here we can see the score like performance, accessibility, and the metric score also. Here we can also see the different diagnostic opportunities for all the metrics also. So what we can do to fix it. So this we can use it and try to fix. And after fixing, we can again run this tool to see the lab data score. And for the field data, we need to wait for a period of 28 to 30 days till all the real users interaction is recorded. But lab data helps to a great extent. So same applies for desktop also. So this is one of the way. The other way, we can go to the Chrome developers tool. We will see the Lighthouse. There we can, for the scores, we can select the mode as navigation. Device like what we want, like we can select mobile or desktop. See for the scores in different categories. I'm just selected performance for now. So the same score lab data which we noticed in the PageSpeed Insight, something similar you will be seeing in the Lighthouse also. So this is an alternate way. So here it will show us the score as well as the diagnostics and what we can do to fix it. So after going through the web vitals and basically how we can measure them. So there are three important web vitals which Google is considering for score computation and downsizing your SEO or upsizing it. So first one is LCP. LCP is basically your largest contentful paint. Whenever your web page is loaded, so the time it takes for loading the content in the first viewport, that is the first fold, that score is being measured by LCP, largest contentful paint. So let me show you through the page itself. So for example, this page is loaded. So the time it takes for this section to load, that is the content in the viewport on the first fold. So that is being considered for your largest contentful paint. So there are certain ways to optimize LCP. Like these are the generic ways which will help to improve other web vitals also. First is we should optimize the images because images, if they are of the big size, it will take more time to load. So we should optimize the images. We should use images properly, either PNG or JPEG. We should optimize them and try to convert into a WebP format, which is basically a lighter format as well as maintains transparency like PNG. And for the fonts which are loaded, we should use font display as swap so that till the first fold content is loaded with the custom fonts, which can take time. The system fonts will be used. So it will also help to improve performance. We should always preload the critical resources like your hero background image or other images so that it doesn't impact LCP. And whenever the page is loaded, so browser has the directive to basically download these resources. So it helps also in LCP. We should reduce the DOM size for sure. It is like for all the standard metrics as well as performance. We should have less number of the DOM nodes because always HTML executes from top to bottom. So we should reduce the DOM, try to have the DOM nodes like as less as possible. We should avoid keeping the JavaScript in first fold, or if we need for sure, we should either defer or async as per the need. What will they do? For example, whenever the JavaScript is executed, they will only load if we use async, but it can impact the HTML parsing. So we can go with a defer. Defer is preferred because in that way, once your HTML is parsed and the JavaScript is downloaded, then only it will be executed. We should always use the minification for HTML, CSS, JavaScript because our computer machine doesn't need the beautified code. It just works with the minified code and it reduces the size also. We should always inline critical CSS because if we will be using an external CSS, it will take time to download that external file. So it's advisable to inline critical CSS, which is in the first fold, that is in the viewport. We should also avoid hosted external videos in the first fold unless necessarily. And the last point is always necessary. We should always optimize web hosting, caching, CDN, which will be covered as a separate session. So this was the first matrix, largest contentful paint. So the second matrix, which is being used by Google, is cumulative layout shift. Whenever our page is loaded, if there is some stability, visual stability of that is measured by this metric, cumulative layout shift. For example, if the page is loaded and we don't reserve the size for the image, so if you see on the right-hand side, that section goes down. So it provides a bad user experience. Or if the page is loaded and we have not properly designed the page, user ends up on clicking a different button, which was not intended. So it can reduce the conversion as well as impact the layout of that page. So it is recommended to fix the cumulative layout shift, and the score recommended by Google should be less than 0.1. So there are certain ways we should fix it. We should provide width or height for the images, iframes, or other embedded elements. Because since we are having the responsiveness, if we are providing width or height, we should use the aspect ratio. We should also reserve space for the elements like ads, etc., to avoid layout shift whenever the page is loaded. And there are certain ways we can check for the elements which are causing layout shift and fix it. So first way is the same. We either go to the page speed insight or lighthouse, check for the elements which are causing layout shift. We go to, for example, this section here, CLS. Here we if the CLS is there, it will show us the elements causing layout shift. We can identify them and fix it. Some of the diagnostics you will see like always do not have an explicit width and height. So this I mentioned, like we should provide width or height and as well as the aspect ratio. So this is first way. The second way is we can go to the page. On load, we can record the performance using the Chrome's performance thing. We can record the performance. We can see like in the performance profiling, which elements are causing layout shift. So we can identify those and fix it. It will also give us the, for example, here we don't shift. If there are a layout shift, we will see some red areas for the layout shift. So there are some ways, and also we can use some extensions also like Core Web Vitals or whatever works for us. If this show a score of more than 0.1, that is, it is in red, then we can try to fix it. Then the next metric, which was introduced recently in March 2024, is interaction to next page. So before this metric, we used to have FID. So the FID is replaced with this metric because it measures more responsiveness of the page. So whenever the user make all interactions on the page, for example, like any click, tap or keyboard or interaction, so it measures all those interactions. Whatever the interaction has the biggest latency, so that score is being computed in INP. We should strive that INP should be less than 200 milliseconds. That is all the interactions on the page. The interaction which is having the maximum time should be less than 200 milliseconds. So that is like whenever you interact and the next frame is painted after interaction which was intended. So that score should be less than 200 milliseconds. So there are several ways to measure fix INP. So fixing INP is a bit tricky, but some things we should keep in mind that we should always optimize our CSS, JavaScript, reduce unused CSS, JavaScript. Using the Chrome, we can easily identify the code which is unused, try to remove this. So one thing is like, as I mentioned, DOM, we should always reduce the DOM size node elements so that the presentation delay can be minimized. We should always optimize the images, animations, like because they can be used everywhere, the images and all. the most important thing for fixing INP as of now is we should avoid the long task. Like for example, task can be any task like rendering, parsing HTML or running JavaScript. We should divide that long task into chunk of smaller tasks. So it will for sure help to fix INP. So let me show you like how we can measure INP. So measuring INP is a bit tricky since it's related to all the interactions on the page. So what we can do one way, let me go to the Lighthouse. Here we can basically select the mode as time span. Device I'm selecting is mobile. Categories is performance. Let me also go to the device mode for this. And also once we're doing performance profiling, I forgot, we can also have the settings. Like if we know that our device users are basically using slow 3G, fast 3G, we can change the network and also we can do the throttling. So we can try to emulate the real user experience. So this is also a way. So for INP, let me reload the page. So we have started the time span. So we can do all the interactions on the page, like clicking the hamburger or going here or clicking on clear, and then like closing this close button. There might be other interactions. So we have to, or clicking on the link can be a simple interaction. So once we do all the interactions, we basically click on end time span. So once we do all the interactions on the page, we will be seeing the score. Currently it's 60 ms, which is fine. It should be less than 200 ms, but if it is more than 200 ms, we should fix that. For fixing, we need to use the same step which we do for CLS, but in a different way. Since it is not related to the page load, we can basically do the start profiling and basically do all the interactions on the page, whatever we want. Same thing, like clicking this or clicking this, all the interactions, and then we click on end button. Like once the interactions are done, there we see like which main thread is taking more time, that we can try to find like is like particular JavaScript is taking more time or particular thread, so that we can try to optimize it. So fixing INP is a bit tricky, but it's a same like important metric which was introduced recently, and I think all the websites, AEM sites should strive to fix it. So after going through the three main web vitals, Adobe also realized the need for core web vitals, making the sites performant, since like from past 2-3 years, it's very critical. So it is suggested if there are some new users who are going for a new project, they can use the edge delivery services, or if someone is an existing site, they want to check 1-2 pages with the edge delivery services, so they can develop or change their code structure and design to see the compatibility with edge delivery services, along with making the optimizations which we have seen till now. Using edge delivery services helps to improve the web vital score significantly, and Adobe also claimed it, and they are trying to basically promote it. So this can be checked. I'm not going into edge delivery services, it's a separate session. Yep. So after discussing core web vitals, like why we need to fix it, so there are some strategies for optimizing the code. I'm starting with the front end code. Some of those might be already discussed in the initial sections, but I'm just going through a quick recap of those. So one is preload connections. So if we are some important critical resources like the hero background image or some fonts which are in the first fold, we can basically preload that, so that the time it browsers automatically starts downloading rather than waiting, and it helps to improve the performance. Just one thing to note with preload, always use the correct as attribute, like either image or font, as I mentioned in the screenshot, so that it avoids double loading. And there are some other things also, like we can do prefetch, pre-render, and pre-connect. So I'm not including that in the session. Those are not that important browser. Like the preload directive is a compulsory or mandatory browsers. Others like as browser see as per their fit, but they can be also used in some scenarios. So that can be also explored. So second thing is we should always optimize our CSS and JavaScript code. So that we discussed earlier also. We should load JavaScript either as an async or a differ as per the need. As I mentioned, if we don't have a script which is interfering with the DOM, we can use async, else we can go with the differ, so that once the script is downloaded, then it is executed after the HTML parsing. So we can use that. We should use out of the box gzip compression. So AEM supports it. There's an OSGI configuration. So we should minify and use gzip compression, which will reduce the HTML size And as I mentioned, the less size of HTML, CSS, and JavaScript is recommended. And one thing which is like also supported out of the box by AEM with the image component, that we should all, or if we have a custom development, we should use the lazy load approach, so that the images which are not in the first fold, that is when the page is loaded, not in the viewport or the first fold, that images we should lazy load, because there are many chances that the whole page is not navigated. So if we do doing lazy loading in the initial page load bytes, the lazy loaded image will not be considered. So it will reduce the page size as well as optimize it. So always we should use the lazy loading approach. We should always use the correct file types of our images. If it's an icon, we should use SVG, and if there are images, we should try to use WebP format, or like try to convert your JPEGs and PNG into WebP format, which is a lighter version also and maintains the transparency. We should always use the adaptive techniques. Like if there is no adaptive technique on the site, simple thing we can do, like for the hero image, we can use separate image for desktop as well as mobile, because mobile image are less in size and small. So it will help to improve the performance. And we should always cache the images at the CDN level. So this is for sure compulsory. Then there are some optimizations for the server side, that is the backend optimizations. I will like Devanshu to share.
Thank you, Deepak, for the detailed session on core web vitals. Let me just share my screen. Just let me know, guys, once it's visible to you.
Yep.
So, okay, all right. So while we have talked about a lot from the front-end standpoint, so now the application performance is equally important, that your application server should be performing well, and it should be rendering the pages in whatever the optimized format it can. So first of all, whenever we talk about how to optimize the backend systems or how to optimize our business logics and all of that, first of all, the key point is, in the case of AEM, is to know your component. Unless we know that what all components are there on our page and how much time each component is taking, we can't be able to evaluate that is it the right performance set that we are getting, or is it some component is burning the whole page performance. So for that, we generally have a feature in AEM where we can just switch to the developer mode. On the right side corner, you can see in the screenshot as well, we can just select that mode. And then on the left hand side, on the side rail, you can see the hierarchy of all the components on the page. And it is specifically telling you the server-side computational time that is needed to render this. So at times, even I have seen this, that there could be one single component which is having some slow running queries into it, and which is burning the whole page performance. And then you can easily get to know by this tool on the left-hand side, because it will be taking a lot of time. And then you can evaluate that you need to create an index on top of it. And similarly, same thing goes for your backend optimization as well. Maybe you have written some, backend logic, which is a little redundant, or it is consuming a lot of resources, or IO calls, due to which it is loading slow. So in this way, you can easily find it out, and then you can easily be able to fix it after analysis, whatever makes sense. So next part to it is that, it's a great question to talk about, that when we have all the fancy stuff like CDN, Edge, and everything, why the raw rendering still matters, why the application performance still matters, because everything is getting cached on the CDNs and everything is coming along. So then how does it make sense? So the pointers for that is, number one is that whenever we talk about the authoring UI, because AEM is all about the content management system, which is going to get used by the authors. So those pages, in the case of authoring, always renders live. There is no CDN that is providing those pages. So it really matters how your page performance is for the authors, so that they can easily be able to make changes, publish the pages, and whatsoever activities they do. Next is, at times we see certain clients who do the personalization using the backend logics itself, because it is not possible for them to do it on the front end because of complexity of their backend logic, or whatsoever is the case over there is. So in that case, if your server is performing slow, so your front end rendering is not going to look good. Next is the bulk activities. Definitely, we have all the bulk activities like scheduled jobs. Maybe you have a scheduled job that is pushing all the content changes over the whole day to a specific server, a third-party server, or any other repository activities that happens in bulk. So those consumes directly your application server resources. The next one is CI/CD activities, because CI/CD activities is something that happens regularly. We at least have a single build to the production, usually in a month or so. So every time it happens, we have to clear the cache on CDNs or the dispatchers. And in that case, the content gets served live unless and until the caches get filled. So it really matters how your server is performing in those cases. So let's try to understand that how can we, what can be the root causes of a slow application server performance. One was query, I already talked about it, but why even that? So a performance of a request has a major factor, which is repository access, that how many times you're accessing a repository while rendering a particular resource onto your page. It could be a single component or the whole page, whatsoever it is, the repository access can be a major factor over there. Usually when we see the code that we script down for our components, we often see there is a lot of repository access that is happening, which is unnecessary and redundant, right? So in all of those cases, it kills the performance of the server. But let's try to understand that what is repository access at all. So every time you try to resolve a resource, you try to list the children, you try to get the resource, you try to get the property, you're accessing the JSON repository. And in all those times, whenever you're doing this, in every single option, there are 4 steps that are. Number 3 is initiation of the object. Then also in the additional data. Additional data means, for example, you're trying to list the children and you're trying to find the relevant children who is GCR content, but till now it read 500 other children. So it is accessing a lot of resources over there. So now how can we resolve?
I think Devanshu, your voice is breaking.
Issues? What can be the best way to do that? Number 1 is, and I have seen is it breaking even now? Switching the network. Hello. Is it better now?
Yeah, it is better.
Okay. All right. Are we good to go? So can you help me understand, Deepak, where the voice majorly got broken so that I can repeat that part? Hello.
Yeah, I think
Yeah,
you
you
can.
can. Yeah, you can take the repository
Just
access
give me
from
a
that
minute.
perspective.
Okay. Sure. Uh, uh,
Divyanshu, it seems we have lost you again.
Okay, so till the answer comes, right? So there are other strategies which we talked about, like okay, you guys are like doing once in a month the build pipeline. In such cases, like the cache will be cleared out completely. So in such cases, what would be our strategy kind of a thing? So in a different enterprises, how they are doing is like they will identify first for your website, like what is your top performing pages, maybe like a top page viewed from your analytics report. You can collect like say 200 to 250 pages from your list, and then like whenever you do the release pipeline is clearing the cache, you can write a simple script like shell script or something to do a curl for those 250 and warm up the cache before you actually enabling the traffic as such, right? So that is also one of the strategy that you guys can look for it, so that whenever like the cache is completely cleared out, and then it is serving the traffic, you will not like all the hits comes to your publisher at one single shot of time. So you will already have certain performing pages which is frequently visited will be available in the cache. So that is one of the strategy that you might look for it. Now I will uh, I Deepak, can you share that slide so that I can run through?
Yeah, sure.
Yeah. So here a few other things that I want to pick it up is I'm just giving a general tips. So you know like in the current state, I really want to know what are all my performance issues that I want to have a look at it and where to start my to solve my performance issues from the back end side, right? So front end side, I think Deepak has covered a variety of strategies that you can place. In the back end, if you literally struggling where to start, the first point that you can start with your orlog jar or your request top slow request. In sometimes like you go to the console and see it might not have that every slow request. So the other way where you can actually get such kind of the slow request is there is something called orlog.jar is provided in the Maven repo. You can go and download that as well and put it into your CRX helper folder. And then you can just run a few queries towards it, like I mentioned in the screenshot, like Java orlog.jar. And then it will you can pass saying that okay, what would my top 10 request slow queries or slow request in my system. This you can run it for every publishers, and then you can call it like top 200 to 300 slow request, and then you can go through each and every request and see saying that why it is becoming slow, right? So this will be very handy to get into the bottom of it. And this is also have multiple options where you can also create a graph out of it. And it will also tell saying that where how your server requests are performing. Because when you actually go manually and doing the request log, deep dive into that request log, you might not able to interpret because like every request will have an ID with a response code, and then when it response comes in with the same ID, it will provide what is the response time it take and what is the HTTP status code as well. So it is very tough to debug in the request log directly. So you can use such kind of utilities to ease your process. The other thing is like Deepak has talked about like how you in the front end you can add the JavaScript as a differ or client libs as differ as async. There is no like when you are actually adding a client lib as a category as a GS and CSS, you might not have a direct option to place differ or async. If you are in you are not using a core components or you are using straightforward components, you have to integrate with your third-party libraries like async client, AEM client lib async. There are libraries available in the GitHub. You can download and then put it into your dependency, and that will provide you a flexibility to transform the client libs and accept those differs tags attributes. So you once you implement that, then you can able to put like async equal to true or differ equal to true. Accordingly, it will take. If you are using a core components, that's a screenshot I have provided where the core component itself providing with the model for the client library, where you can inject that model, and then you can it will allow you to add the differ attribute or async attribute, whichever you like it, right? So these are all the things that you can use whenever you do the development. When you're talking about say okay, these are all like a front end how I will improve my performance on the content fragments when I'm using a GraphQL and all. So I will not touch the entire GraphQL as a standpoint. So I will give you certain inputs on the queries, the persisted queries. Whenever you're doing a persisted queries, like there is a default cache header will be available with the current versions and all, which is actually 60 seconds, I guess. So if you want to increase that, you can manually override. It will accept when you writing a query, when you're doing a put, it will actually put the message control, where you can add the header as well. And for the post call as well, it is supported. So these are all the references that I have placed it here.
Thanks, Venkatesh.
Can I
Devanshu,
start?
yeah.
Yeah.
Yeah,
Audible now?
Devanshu, go ahead. Yeah, it's audible, Devanshu. Go ahead.
Okay, sounds good. Let me open the slide back from where we left.
Okay, yeah. So we were talking about, sorry, just wanted to go back with a small recap, quick one. That we were talking about the repository access, that how it happens, and what are the steps that happens while you access the repository. So we are at the point where we wanted to understand that how we can limit this, the multiple repository accesses. So step number one is to resolve the resource once and reuse that object. Because I see many times when we have written the same method again and again, or maybe different methods altogether, where we are passing the path of the repository which we wanted to access directly in the form of string, and we are trying to resolve it again and again in each and every method, which is doing again and again the repository access. So it's always a good practice to resolve the resource only once and then keep on passing to different methods, however you wanted to do it. This takes us to the next pointer where we wanted to talk about, means it's similar to it, when we should not be converting the resource to string and then string to resource, because what we generally do is we take a child resource, we convert the string, we pass it to the another object, and then we get the resource again. It's similar to what we have talked about in the first one. Next is sling resources to GCR resources adaptation. We should never do it. Sling resources have some sling overhead, but still the abstraction, how it is being handled, is way more performant. And we should only adapt sling resources to GCR resources only when it's needed, right? Fourth one is my favorite, where we keep on creating the new resource resolver again and again, each and every method. We initiate a resource resolver, we get the stuff done, close it, and we do it in every single method. Rather than doing that, I think that we should be doing it in the driver method at the top. We keep on calling all the methods, keep passing the resource resolver over there, get the stuff done, and at the end, close the resource resolver. In that way, we should just try to avoid creating multiple resource resolver and accessing the repository with new resource resolvers every time. The next one is at inject, because we try to inject many resources into our Java classes or the components. So in all of those cases, if you are using inject, start not using inject at all. The reason is because the inject itself try to find out the best possible the injector from the available injectors and try to inject those particular resources using that particular injector. But the problem over there is that if, for example, the resource in itself is not available, so it will keep on going to all the injectors and then try to conclude that it is not available at all, or it is a null. So try to specify the injectors which you are trying to use. If you're trying to inject the resource, child resource, use child resource. If you're trying to inject a property, use value map value, and so forth and so on. Just avoid using at inject. Use the specific ones. Now the question comes is, okay, we got to know what are the issues, that the issue is repository access. We know how to resolve it, but how do we get to know how many times our repository is getting accessed? So for that, we have ways. We can just create a single logger for access logger.operation, which will show you a stack tree wherever you are creating a GCR resource object. Also, you can create a trace for access logger.statistics, which will log the number of created GCR objects using the resources on it. So in this way, I think this will really help you out, and be mindful whenever you are doing repository accesses, and think through that if you can avoid it, or is it really necessary. So next point goes to is the sling dynamic include. So at times we generally have a page where we have one or the other component which needs to pull the data dynamically from the publisher. So for that point, generally what I have seen in practice is that we generally just go ahead and do a no cache for the whole page, which eventually won't cache the whole page, and the whole load goes onto the publisher. Even when it's just about one single component on that page, which needs to get loaded dynamically. So in those cases, Sling Dynamic Include comes into the picture. What you can do is go ahead, create a OSJ configuration for Dynamic Include after obviously using the OSGI component for Sling Dynamic Include, the bundle, and then add the resource type, whatever is your resource type in that configuration. Use a selector, no cache. So what will eventually happen is on the dispatcher end, it will generate a placeholder, what you can see at the bottom. It says /content, my site, home, JCR content container, header.nocache.html. And now what will eventually happen is whenever the dispatchers see this URL, it will try to just request this URL. And whenever the request happens, because we have a selector, no cache, and we have already avoided any request which is having no cache to be served from the cache, it eventually make a request back to the publisher, pull the content and render it. And this way we can get it dynamically included. Next is when we wanted to have a Sling dynamic include, but wanted to include it statically. What I mean is a very usual use case. When we have the header and footer being created by experience fragment. So now header and footer created experience fragment, header, something else got updated in header. So do we really want those 1,000 pages to get just flush the cache? We don't, right? So what we wanted to have over here is in the similar way it should go in the dispatcher or something over there that can just avoid doing that. So in that case, what we can do is the simple hack is there that use the resource type again with the SDI, but don't give a selector over there, because now what will eventually happen is whenever this will come up and get
I think your voice was gone, Devanshu.
Like the way seeing at the bottom, this is at the place where your header is. Now, what will eventually happen is, am I not audible to you again?
Now you're audible, but it broke in between, I think, when you were starting with static approach, right?
Hello, am I audible now?
Yes, you are.
Sorry, I don't know why it started happening just now. Okay, so I was saying that if we wanted to statically include a specific component onto dispatcher cache, so what we can do is we can just create a resource type for that particular component and just keep the filter.config.selector as blank, because now what it will do is eventually create a placeholder in our cache file wherever we are having the header with this path that you can see at the bottom. And now dispatcher will try to access this path, and eventually this path will be cached separately. So now whenever you're trying to publish a page, publish the header in the experience fragment, it is creating a cache separately, as you can see in the diagram as well. And now it is getting injected while the page loads by the dispatcher, so that you are keeping your cache for the header, footer separately, and hence you are able to even manage the performance. Now, the next point here is version client clips. I think this is one of the way to eventually save the performance of your JavaScript and CSS loading on your page. At the same time, making sure that whenever something gets updated in your JavaScript and you do a deployment, it still get cached on the client's browser using obviously the cache control headers, because there could be the cache control headers that you must have added to your JavaScripts. But now let's just assume a simple scenario. Let's go with that. Step number one, I made some changes to JavaScript. I deployed a new application onto the server with some cache control rules. Maybe the cache control says the max age is 1 day or 2 day, whatever. Now on the same day, for some reason, I need to redeploy it because that JavaScript is having some issue. So now when we deploy it again, because the JavaScript is already cached on client's browser, it won't get refreshed. It will still keep serving it from the browser cache. And that's a challenge over there. To solve this issue, what we can do is we can go with the version client lib. So what version client lib will do is every time a client lib URL is generated, it will always have a random MD5 hash in it. And this MD5 hash will eventually make sure that with every deployment, it gets changed. It's just a random string. So now in deployment 1, you may have abc.js at the end as a selector before that, and your browser must have cached abc.js. But now when you redeploy after making the changes, it may be pqr.js. So now your browser doesn't have the cache for that URL. Eventually, when it's the same client lib altogether. So in this way, you can enforce longer TTL as well. You can have multiple days and maybe a month long TTL, because you know whenever you will update anything and deploy it, it will eventually get flushed, or even if not get flushed, it will have a new URL and then it will be consumed for the first time directly from the servers or the origin. I think this covers most of it, which is version client libs, how we can use the Sling dynamic include, and how we can maintain the performance on the backend side. Thank you so much. Deepak, you can take over.
Yeah, thanks, Devanshu, Venkatesh. I think we are good. Venkatesh covered the initial part. We will share the